Friends, in this video we are going to study the application of BJT as an amplifier. So what is amplifier? The amplifier converts small level input signal into large level output signal. So it increases the amplitude of signal. There is increase in the intensity level of the signal. So if you want to use BJT as an amplifier, first we have to bias that BJT in active region. Means the emitter base junction should be forward bias and collector base junction should be reverse bias. So for this biasing, I can use any biasing circuit. That can be simple biasing circuit, collector to base bias circuit, or voltage divider bias circuit, which is also known as cell bias circuit. Here I am going to use the voltage divider bias circuit. Why? Because the stability of Q point is highest in voltage divider bias circuit. So what I'll do, first I'll draw here the voltage divider bias circuit. So first I'm having the transistor, the input terminal is base, output terminal is collector, and common terminal is emitter. So here if you draw the voltage divider bias circuits, there are four resistors. One is in series with collector, second is in series with the emitter. Then here there are two resistors, R1 and R2, which are actually acting as a voltage divider. So here R1, then R2, and I can connect here a supply VCC with respect to this reference point, that is ground point. So this is simple voltage divider bias circuit. It is also known as cell bias circuit. Here with the help of, by properly adjusting the values of R1, RC, R2, RE and VCC, its polarity and magnitude, we have biased this transistor in active region, that is base emitter junction is forward bias, collector base junction is reverse bias. So this is just biasing. We haven't collected any input signal, right? Now we have to connect the input. Obviously, as it is common emitter configuration, input we have to connect between base and emitter, that is here in between base and emitter, and output we have to measure across the in between collector and the output common point, emitter point. So here I'll connect the input signal, which is AC, and this input is applied between the base and emitter terminal, because it is common emitter configuration. And I'll measure the output in between the collector, this is nothing but the output voltage in between collector and the here the emitter terminal, which is equal to V. That output is equal to, this output is actually equal to, it is the voltage at collector point with respect to ground, hence it is nothing but total voltage VCC minus drop across RC. So that is why it is equal to VCC minus IC RC, right? So this is the output voltage. Now here already with the help of this voltage divider bias circuit, we have biased this transistor in active region. But friends, if your input is not pure AC, if it contains some DC part, what will happen? That DC part which is coming from input side will affect the biasing of this transistor, and it may not operate as an amplifier. So that is why this input should be pure AC. Hence what we'll do, we'll block the DC part which is present in this input. So that is why here I will connect a capacitor which is known as input coupling capacitor C in, which will block the DC in the output. Similarly, DC part present in the input. Similarly, in the output you may have DC value, and this DC value you will get due to the Q point, which is DC operating point, right? Because the output will swing above and below the Q point. And if you want the pure AC, again what we can do, we can connect here the capacitor at collector terminal, and it is known as the output coupling capacitor, CO, output coupling capacitor. The basic function of this capacitor is to block the DC. And if you want to increase the gain of this transistor, you can connect one capacitor in parallel with the RE, and it is known as the emitter bypass capacitor. It increases the gain of the transistor. Without CE, the gain of transistor is limited, and with CE, the gain of transistor increases. Now let us see the operation. So here, if you increase the input, say input is increased, what will happen? There will be increase in base current, and we know that in transistor, the collector, this common emitter transistor, collector current is beta times IB, that is output current is beta times IB. So that is why with increase in IB, what will happen? The collector current will increase, and if the collector current is increased, see, RC is constant, VCC is constant, hence if the collector current is increased, output will decrease its magnitude. So that is why here, if you consider the input and output, if input is increasing, output is decreasing. So for that is why there is 180-degree phase shift. There is 180-degree phase shift between input and output, right? And how it is acting as an amplifier? See this beta factor. Beta is current amplification factor. So input current is IB, but the output current is beta times IB. Typically this value of beta, it is from 100 to 200. So that is why this collector current will be the amplified version of the base current. So this is just, I am considering the DC operating condition. Now if you consider the AC input, I explain with the help of waveform. See here, the first waveform, right, that is nothing but the input. So this input, which is nothing but after, I am showing it after capacitor, after input coupling capacitor. So here you will have 0 DC level, and the input is fluctuating above and below the 0 level, right? Corresponding to this input, right, there will be the flow of base current, but this base current will not be purely AC, because due to the biasing of this transistor, there will be some DC level of base current, and above and below which the base current will fluctuate. So if this small IB, small b means the resultant base current, which will fluctuate above its Q point value, IBQ. And if I consider this, we'll take the projections here. So here there is increase in the base current, decrease in the base current, increase, decrease in the base current above and below the Q point. Corresponding to this, there will be the collector current, IC. Again, this collector current will fluctuate above and below its Q point value, right? So I'll get increase in the collector current, decrease in the collector current, increase, decrease, increasing, decrease. You'll say, sir, these two base current and the collector current, their amplitude seems to be same. Here the base current is in microampere range, while the collector current is in milliampere range. So that is why it is amplified version. Now if you consider the last waveform, output voltage waveform. What is output voltage? Output voltage, it is equal to VCC minus ICRC. So this output voltage, it will fluctuate above and below its Q point value, and its Q point value is VCEQ. When there is increase in the collector current, the output voltage decreases. So that is why there is 180-degree phase shift. There is 180-degree phase shift between input and output. So these are the curves, these are the waveforms of the BJT as an amplifier. Instead of this voltage divider bias circuit, you can use any biasing circuit, but as the Q point stability of this circuit is more, we are using this circuit in this amplifier. If you consider this amplifier, this circuit, in this circuit there is only one stage of the transistor as an amplifier. Now what is multi-stage amplifier? If you give output of this first stage as an input to the next stage, what will happen? It will be two-stage amplifier, and in two-stage amplifier there will be the multiplication of gain. Say if the gain of first is say G1 and gain of second stage is G2, then resultant gain will be G1 multiplied by G2. So that is two-stage amplifier. Again, if you connect the output of the second stage as an input to the third stage, it will be three-stage amplifier. Likewise, you can have multi-stage amplifier to increase the gain, but here it is single-stage amplifier. It is single-stage amplifier, and here the DC supply is coupled. DC supply is coupled with the help of resistors. The input and outputs, they are coupled with the help of capacitor. So that is why this circuit is also known as single stage RC coupled common emitter amplifier. Single stage RC coupled common emitter amplifier. So that's it. Thank you.